Hello students, today we are doing sets, chapter 6, exercise 6c. In today's exercise, we are going to see how we can represent sets in different ways. So we are starting with page 58, question 1, which says, write each of the following sets in the roster form. Now roster form is one method in which we can represent sets. Now the question given to us is this. We have to represent this statement given here in the roster form. And what is the statement? The set of 5 numbers, each of which is divisible by 3. So what do we mean when we say roster form? In the roster form, there are elements. We have elements in that set and they're all separated by commas and we put them within curly brackets. Okay, so let's start. Now, to represent this statement in the roster form, I'm going to put curly brackets first. Now, let's read the question. The set of 5 numbers, that means this is a set which has 5 numbers. And what kind of numbers are these? Each of which is divisible by 3. So there are 5 numbers and each number is divisible by 3. That means we just have to write the answers that we get when we multiply 3 by any number, or to put it simply, the tables of 3. So let's write down 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12 and 3 fives are 15. So we have 5 numbers here and each of these is divisible by 3. So we close the curly bracket. So this set is in the roster form. So roster form is when you have all the elements within brackets and each element is separated from the other with the help of a comma. Question 2. The set of integers between -4 and 4. Okay, so this set has elements which are all integers between -4 and 4. I hope all of you remember the number line for integers. This is how it is. Okay, so we have 0 in the middle here and we have all the positive numbers to the right and all the negative numbers to the left. Now this set, according to the question, it says we have to write all the integers between -4 and 4. So -4 is here and 4 is here. We are going to write all these in the set. So let's start that. Again, we put curly brackets and we write all those elements. So what are the elements? -3. We start from -3. -3, -2, -1, 0, 1, 2 and 3. So these are all the elements of this set. It is a set of integers between -4 and 4. Question 3. Now what is this statement given to us? This is known as the set builder form. So this question is in the set builder form. Now how do we read this? Okay, we say x and now the colon here says is such that, so I'll read again, x is such that x is a letter in the word school. So we are talking about all the elements in the set and x will represent each element in that set. So let me read this question again. X is such that x is a letter in the word school. So the question given to us is in a form known as the set builder form. Now we need to write in the roster form. So let's put curly brackets and let's write the answer with all the letters of the word school. Now let's keep in mind we need to write all these letters one by one, separate them by commas. They should all be small letters and we cannot repeat any letter. So let's start. S, C, H, O. Now I'm not going to repeat O. So I'll leave out that O and write L and now close brackets. So I have this in the roster form. Next question. Again, the question is in the form of a set builder method. So let's read this question and understand it first. X is such that x is an odd natural number between 10 and 20. So keep this in mind. Odd numbers, natural numbers between 10 and 20. So let's write that down. So we start with curly brackets and think of all the odd numbers between 10 and 20. So 11, 13, 15, 17 and 19 are all the odd natural numbers between 10 and 20. Question 5. Vowels. Be careful. Vowels used in the word America. So the next set is made up of vowels used in the word America. So start curly brackets. Look out for the vowels A, E, I, A. Okay. Now we write A, E, I. We don't write A again because it's already there. So we close brackets. Next one. Consonants used in the word Madras. So consonants and the word is Madras. Now let's start our answer. Curly brackets. Now let's look at the consonants M. Leave out the vowels. D, R and S. Okay, let's write that. M, D, R and S. Close brackets. Question 2. Write each given set in the roster form. So once again, we've been asked to write the set in the roster form. So here we are asked to write all prime numbers between 1 and 20. So let's write that. So again, we start curly brackets and prime numbers between 1 and 20. 2, 3, 5, 7, 11, 13, 17 and 19. So this is the set of prime numbers between 1 and 20 and we have put it in the roster form. Next one, the squares of the first 4 natural numbers. Okay, first let's write down the first 4 natural numbers. So let me write it down here. 1, 2, 3 and 4. What do we mean when we say squares? When I say square, I put this on top. 1 square, 2 square, 3 square and 4 square. What do I mean? I multiply 1 twice. That's the meaning of square. Okay, I multiply 2 twice, 3 twice, 4 twice. Okay, so twice I've multiplied. Now what's the answer that I'm getting? 1 ones are 1, 2 twos are 4. 3 threes are 9, 4 fours are 16. So these are the squares of the first 4 natural numbers and that is going to be my set here. So let's start the curly brackets and write down all those answers. 1, 4, 9 and 16. This is my roster form and I have my elements there. Next question. Even numbers, all even numbers between 1 and 9. Okay, so let's start curly brackets. Even numbers are 2, 4, 6 and 8. So it's less than 9. So these are my elements and I put them in the roster form. Next one, the first 8 letters of the English alphabet. So 8 letters. So this set has 8 letters of the English alphabet. So let's start. A, B, C, D, E, F, G and H. Yes, now we have 8 letters and they have formed a set and we have put it in the roster form. Question 5. The letters, all letters of the word basket. Okay, so the next set we're going to start. When you get words, remember you have to write each letter separately, put a comma after each and you should not repeat any letter. So B, A, S, K, E, T. Close brackets. So we've got that in the roster form. 4 cities of India. Okay, so the next set will have 4 elements and what are they? Cities of India whose names start with the letter J. Okay, so the next answer will have 4 cities in the set, and all those cities will start with the letter J. So I have it here for you. Jaipur, Jodhpur, Jamshedpur and Jalandhar. So they all start with the letter J. So can you see that? They all start with the letter J. Okay, next one. Any 4 closed geometrical figures. So closed figures are rectangle, square, circle, triangle. Okay, so you have all these. So we have a square, a rectangle, a circle and a triangle. These are 4 closed geometrical figures. So the next set is made up of that. Question 8. Vowels. So here we should be careful. We're talking only about the vowels used in the word Monday. So let's look and see. O, not N, not D, A. So we only have O and A. So let's write that down. Start curly brackets. O and A. This is the set with 2 elements O and A. Single digit numbers that are perfect squares as well. Okay. Now, what are all the single digit numbers that we know? 1, 2, 3, 4, 5, 6, 7, 8 and 9, isn't it? Okay. So here, okay, so first I have written down all the single digit numbers starting from 0 up to 9. Now in these, which are the numbers which have formed squares? Okay, so let's see. Square means 0 square, 1 square, 2 square. This is what I mean when I'm talking about squares. It means I multiply each digit twice. So 0 into 0 will give me 0. So 0 is a perfect square. 1 into 1 is 1. Okay. 2 twos are 4. 3 threes are 9. 4 fours are 16. 5 fives are 25. 6 six are 36. 7 sevens are 49. 8 eights are 64. And 9 nines are 81. So let's write down a set. Okay, now let me pick out from these the single digit numbers. What are the one digit numbers? 0, 1, 4 and 9. All the others, as you can see, are two digit numbers. So what are the single digit numbers that are perfect squares as well? 0, 1, 4 and 9. So 0, 1, 4 and 9. Now we go on to question 3. Write each given set in the set builder form. Okay, now we need to understand our question well. So let's look at the question. What do we have here? 2, 4, 6, 8 and 10. As you can see, they are all even numbers, but they are less than 12. And they're all natural numbers. Even natural numbers less than 12. Now when we write in the set builder form, so let's write this in the set builder form. This is how we write. Now we always start by saying x is such that x is, what is x? We have to look at the question. They're all even natural numbers less than 12. So x is such that x is an even natural number less than 12. You write it out in words. So set builder form is a little formula. This is another method of showing sets. So it's like a little formula which is telling us what the actual elements are. We don't give the actual elements in the set builder form, but it tells us what the actual elements of a set will be. So if you just look at this, you can understand that X means each letter, each element which is there in that set is an even natural number less than 12. So this is how we write out the set builder form method. And we read it like this. X is such that X is an even natural number less than 12. Question 2. Now we have 2, 3, 5, 7 and 11. Now we need to look carefully and see if there is a special meaning to these numbers. In the first question, we found out that they were all even numbers. Now here some numbers are given. What are these numbers? If you see carefully, they are all prime numbers. 2, 3, 5, 7 and 11 are all prime numbers less than 12 again. So let's write this in the set builder form. X is such that X is a prime number less than 12. So what do we mean when we say X? We are talking about each element. X is 2, X is 3, X is 5, X is 7, X is 11. So we are talking about each element in that set. So according to this, X is a prime number less than 12. Let's go on to the next one. Question 3. We have 3 months of the year: January, June and July. What is special about these? Can you see that they're all names of months of the year which start with the letter J? Yes, we can see J for January, J for June and J for July. So let's put it in the set builder form. X is such that X is a name of a month of the year starting with the letter J. So what is X? It's a name of a month of a year. So January, June and July is the name of a month of a year starting with the letter J. So as you can see, the set builder form is not giving us the answer directly, but it is telling us through a little formula what the answer can be. So it's saying it's a name of a month, isn't it, of the year, and what are these names? These are names that start with the letter J. Okay, question 4. Now we have A, E, I, O, U, and what are these? These are vowels of the English alphabet. How do we put it in the set builder form? We say X is such that X is a vowel of the English alphabet. Okay. Next question. Tuesday, Thursday. What is special about this? Tuesday starts with T and Thursday also starts with the letter T. So Tuesday and Thursday are names of days of the week starting with the letter T. Okay. So X is such that X is the day of the week whose name starts with the letter T. It's like a little puzzle, isn't it? A little riddle. Okay. So there's no answer directly, but through this sentence, through this method, we should be able to find the answer. 1, 4, 9, 16 and 25. Now what are these numbers? Do you recognize 1, 4 and 9? Okay, we used this earlier. This was one of our answers which told us these are perfect squares. Okay, so we took this number and we found out. Now let's see what is 1. Okay, 1 is the perfect square of the number 1. 1 into 1 will give us 1. What about 4? 4 is 2 into 2. So, okay, now take the next number that's given there, 9. 9 is, okay, 3 into 3. Now the next number given to us, 16. So 16 will be 4 into 4. Okay, and the last one given to us is 25, which will be 5 into 5. So the numbers given to us here are all perfect squares. And since 0 is not there, these are all natural numbers. These are all natural numbers. So how do we write that? X is such that X is a perfect square natural number less than 26. Because there are many more natural numbers, perfect squares, but we are talking only about those that are less than 26. Question 7. 5, 10, 15, 20, 25, 30. What are these numbers? These are all multiples of 5, isn't it? So let's write that. X is such that X is a natural number and a multiple of 5 up to 30. So from this riddle, it's like a riddle, isn't it? From this we can understand the answer is 5, 10, 15, 20, 25 and 30. So what we did so far is a set builder method where We learned not to write the actual elements but to use a little formula so that we can get our answer just by reading that. Now question 4 says, write each of the following sets in both the forms, the roster form and the set builder form. So let's start. Set of all natural numbers that can divide 24 completely. Now what is that? Now if I take the number 24, what are the numbers that can divide 24 completely? That is all the factors of 24. 1 into 24. 1 and 24 can divide 24 completely. Let's take 2. 2 into what is 24? 2 12s are 24. Let's take 3. 3 8s are 24. Let's take 4. 4 6s are 24. That's it. So these are all the numbers that can divide 24 completely. They're also known as the factors of 24. So let's write down the roster form. So let me start. 1, 2, 3, 4. Then I have 6, 8, 12 and 24. So I've written all those numbers in the roster form by placing commas after each and putting them within curly brackets. Now I need to write the same thing in the set builder form. Set builder form is easy because you just have to take it straight from the question. So I am writing this. X is such that X is a natural number that can divide 24 completely. If you notice, I've taken it straight from the question. I've taken it straight from the question. So you can do that. You can take your set builder form from the question but put it in this form. X is such that. That is how you need to start your set builder form. Question 2. Set of odd numbers between 20 and 35. Okay, let's write the roster form. All the odd numbers 21, 23, 25, 27, 29. Now I need to get it between 20 and 35. So I need to continue 31 and 33. So these are all the odd numbers between 20 and 35. My set builder form. X is such that X is an odd number between 20 and 35. Again, I've taken it from my question. I just need to start this way. X is such that X is, and what is X? An odd number between 20 and 35. Question 3. Set of letters used in the word Calcutta. So I can use all the letters here. So let's start. Don't repeat any letter and place commas after each. So C, A, L, C, I will not write again. It's already there. U, T, again it says T. I'm not going to write because it's already there. And A is also there. So that's it. These are the elements of this set. How do I put it in the set builder form? X is such that X is a letter used in the word Calcutta. Again, from the question and starting this way. So it's easy to write a set builder form. Next one, set of the names of the first 5 months of the year. Okay. In the roster form, when we write the first 5 months of the year, we start by saying January, first 5 months, and then February, March, April, and May. So these are the first 5 months of the year, and these form the elements of my set, and I put it in the roster form. Set builder form, X is the name of the first 5 months of the year. Again, from the question, starting with X is such that. Question 5. Set of all 2-digit numbers that are perfect squares as well. Okay, so what we will do is we'll take down our numbers up to 9 and see which are the perfect squares and 2-digit numbers. Okay, so let's see. 0 square, 0 into 0, 0. 1 square is 1. 2 square, 2 twos are 4. 3 square, 3 threes are 9. 4 square, 4 fours are 16. So now we are starting the 2-digit numbers. 5 square, 5 fives are 25. Now let's continue and see 2-digit numbers. We need to get all 2-digit numbers. 6, 7, 8, 9. Let me write up to 9 and see. 6 sixes are 36. 7 sevens are 49. 8 eights are 64. 9 nines are 81. So up to this we have 2-digit numbers and perfect squares also. So let's write down the roster form with the answers here. So start with curly brackets and let's write down all these numbers: 16, 25, 36, 49, 64 and 81. So these are all the set of 2-digit numbers that are perfect squares as well. Okay, so let me take this off. The set builder form: x is such that x is a 2-digit number and x is a perfect square. Okay, so again we have got this from the question itself. So for the set builder form, look for words which are already there in the question. Now we go on to question 5. Write in the roster form. So it's only the roster form. The first 4 odd natural numbers, each divisible by 5. So the natural numbers that are divisible by 5 will be, let me just write it down, 5, 10, 15, 20, 25, 30. Let me stop at 30 and let's go back to the question and see what they're asking us. The first 4 odd natural numbers, odd. So let's pick out the odd numbers: 5, 15, 25, and we need one more number, and that will be 35, because here they're saying the first 4 odd natural numbers, each divisible by 5. So let's start our curly brackets. 5, 15, 25 and 35. This is our answer. Question 2. The counting numbers between 15 and 35, each of which is divisible by 6. Okay, so that means we need to take numbers that are between 15 and 35 and those numbers should be divisible by 6. So let's start. We'll say it orally. After 15, 16, not divisible by 6. 17, 18, yes, 18 is divisible. 19, 20, 21, 22, 23, 24. Yes, 24 is divisible. We are looking at all numbers between 15 and 35 which are divisible by 6. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. That's it. We can't go beyond 35. So our answer is 18, 24 and 30 are the elements of this set. Question 3. The names of the last 3 days of the week. Okay, let's put it in roster form. They are Friday, Saturday and Sunday, and put them within curly brackets. Question 4. The names of the last 4 months of the year. Again in the roster form, within curly brackets we have September, October, November and December. With that, we come to the end of exercise 6C. In our next video, we will continue with exercise 6D. Thank you, children.